This is a CCEA AS Pure Maths past paper. It's from May 2022, and we're looking here then at question number 2. So there's two different parts to this, unrelated to each other. So the first one is write 2x squared plus 4x minus 5 in the form here. Hopefully you can see that's the equivalent then of completing the square. So to complete the square, we need to have a 1x squared here. So we need to take out a factor of 2. So it's then going to be x squared plus 2x minus 5 over 2, or 2.5. So what I normally do then is I half this 2 here. So I then, over to the side, I would consider x plus 1 all squared. That's x plus 1 upon x plus 1, giving me x squared plus 2x plus 1. So I know x squared plus 2x plus 1 is x plus 1 all squared. So I start to rearrange this then. This gives me x squared plus 2x, so that bit's good, but it gives me an extra 1 that I don't want. So I need minus 1 minus 5 over 2. That gives me 2 upon x plus 1 all squared minus 7 over 2, and that's effectively it in the correct form. I should maybe a square bracket there, but hopefully you're happy enough with that. Part 2 then is hence state the minimum value of 2x squared plus 4x minus 5 and the value of x at which this occurs. So they're happy enough for you just to state it. So we have, let's write it out again. So we have 2, do the square bracket this time. Couple of different ways of writing that. I can get rid of my square bracket here. It's going to be 2 upon x plus 1 all squared minus 7. So it's going to be the minimum value. So the smallest value we can make this whole thing here is going to be 0. Why is that? If you stick in a really small value like minus 10, minus 100, but minus 10, that's going to give you minus 10 plus 1 is minus 9. Minus 9 squared gives you a positive 81. So all of a sudden it becomes a big value. So smallest this can be a 0. That means the smallest the whole thing can be is minus 7. So my minimum value then is equal to minus 7. This happens whenever you put this equal to 0. So that's then whenever x is minus 1. Part B, totally unrelated. In a controlled experiment, the number of bacteria n after t hours is given by n equals 500 e to the 2t. Find the initial value of n. So initial means at the start, and that's t hours. So we're going to put t equal to 0. N equals 500 e to the 2 times 0, which is 0. Anything to the power 0 is 1. So 500 times 1. So my value then is n equals 500. Find in whole minutes the time for n to increase by 48%. So I want it to increase from 500 up 48%. So what's that going to be? 500, just add 48% obviously, is to 740. So we want to work out the time at 500 e to the 2t gives me 740. That gives me then e to the 2t. 740 multiplied by 500, of course 1.48 again. And then we want to take natural logs of both sides. So if we do ln e to the 2t is ln 1.48. By laws of logs, we can bring the 2t to the front. So you have 2t ln e, and that ln e, so it's log the base e of e, so that's just a 1 then. It's going to be ln 1.48. So 2t is ln 1.48. And t then is going to be a half ln 1.48. You put that into your calculator, and you get 0.196, and that is in hours. They want it in whole minutes, obviously, so 0.196 times 60 is going to be 11.76. So that's very hard for you to see. Yep, 0.196 times by 60, 11.76. So in whole minutes, our answer then is going to be 12 minutes.